All right. 7.2, sum and difference identities. Mainly these three formulas are going to be used over and over again. The first half of the homework is going to be super easy, and then the second half is kind of a little strange, but not too crazy. This is a alpha plus beta. My alphas look like Jesus fish, so sorry.
That's what I thought you were saying.
Lowercase alpha. If you're in a sorority, I'm sure you're familiar with Greek letters, right? Alpha, beta. But I mean, you can use whatever symbol you like. You could use Jesus fish if you want. Got nothing against it. Yeah. In math, we tend to use Greek letters for angles. It's pretty common. If you read lots of math books, you'll see that. We also use Hebrew letters in higher level math. We run out of Greek letters, so we start using Hebrew. They're usually reserved for levels of infinity. You're not gonna see that stuff unless you go into mathematics, so don't worry about it. But there are different levels of infinity. So notice there's a pattern. Right? So if it's a sine function, the plus will be plus here as well in the middle. If it's minus, it'll be minus in the center. Cosine is opposite. If it's plus, then it becomes minus. Minus becomes plus. One of my coworkers has a song to memorize this, but I'm not going to sing to you. Don't worry about it. But I do give you formula sheets, right? So you don't have to sing this to yourself. But you can if you want. Make your own memorization song. All right. So this is example one. I'll wait a second, guys. These are a lot of them, I guess. If you have your unit circle, please take it out. It would be helpful. And notice the tangent is the same thing. The sign just swap. Just swap these signs. Oh, wait a second. You guys cool in the first set of formulas? I'm going to start the example. Again, you don't have to memorize them. I just want you to understand them. So the first one's pretty chill. You just need to look up the values on the circle. the whole point is to be able to find the exact value, meaning don't punch this into your calculator, right? Don't give me a decimal. That's not what I'm asking for. This is 5 pi over 4, pi over 6. So this is my alpha, this is my beta. We have a difference for the cosine, right? The difference. So use this one. So cosine 5 pi over 4, cosine pi over 6, plus sine 5 pi over 4, sine pi over 6. Let me double check here. Cosine alpha, cosine beta, sine alpha, sine beta. Yeah, we're good. All right. See, we're just following the formula. Super basic, right? Nothing crazy. So on your unit circle, what is that? Cosine of 5 pi fourths. The x value.
Square root of 2 over.
Yeah. Negative square root 2 over 2. Now cosine of pi over 6. Oh, okay. Plus sine of pi over 4. But negative, right? And then this one should be half. Okay, so technically this is the answer. The only thing left to do is to simplify and add your fraction. That's it. Nothing insane. Luckily, it's the same denominator, so you're going to get negative root 6 minus root 2 over 4. This is not going to combine, right? To combine radicals, you have to be exactly the same. Like if you had root 2 plus 2 root 2's, then you'd have 3 of them. But these are not the same type. This is an apple and an orange. Just leave it alone. Don't let it bother you. You're done. Any questions on number 1? Okay. You pick one where you have to break it up apart yourself. I think I'm gonna move the homework. I haven't posted the submission yet, but it'll be due Tuesday. Okay, give it some extra time, but try not to slack off on the weekend. Right? That doesn't mean wait till Monday. Start sooner, please. It's your life, and whatever. Just my advice. You guys cool on this page? Okay. So there is no cosine 75 on the circle, right? But you can break the 75 into angles that are on the circle. Can you choose 2 of them that add up to 75? What do you think? Yeah, so you can use 45 and 30 instead, and then apply the formula. So even though this is not an exact solution or angle, you can use those 2 to get an exact solution. You break this into, doesn't matter what the order is. You can also pick some other, you could pick maybe a different way to get 75. It doesn't have to be this way. Okay, just as long as it's 75, you're good. All right, so if it's a sum, the formula says this is my alpha, beta, this is cosine 30, cosine 45, minus sine 30, sine 45. And these are all in the circle. So what is cosine 30? 3, square root 3? Sorry, I'm just curious about something. 1 second. Okay, just real quick, side note. 75 was easy to see on the circle, right? Because you can add two numbers, no problem. But what if it was 5 pi 12ths? Could you see which radians would add up to 5 pi 12ths? Like, unless you're a pro at fractions or you could do this in your head, you're not going to see it. And if you can, cool, that's great. But if you can't, just change this into 75. This is 75 degrees. So if you change it into this, then it's easier. So you can always convert whenever you want. So using those ideas from test 1, if you see a homework question with a annoying angle, just change it. Okay. But anyway, just wanted to mention that I'm sure there's one like that in the homework. I don't remember though. Sine 30 is half, right? And these are the same. Double check me though. Yeah. And then we're pretty much done. Okay. Any question on example 2? We found the exact solution. So remember, if I say exact, don't give me decimals. A couple of you did that on the exam for some reason. Okay. Let's do something more difficult. Are you guys cool on number 2? Yeah.
And the very first, like square roots to multiply have to be square roots or anything.
To multiply the inside of a root, yeah, they have to be square roots. So square root 3 times square root 2 will be square root 6. 1 times that would be just itself. If this was a 2, it'd just have a 2 in front. That's all you can do. You could force numbers to go inside the root if you wanted to, but then it wouldn't be reduced. Like you technically, this is the same as this, right? Root 2 is the same as root 8, so you could force it in there, but that's not usually what we do. You guys cool on number 2? I'm gonna turn the page. All right. Remember, this one's kind of weird. It's a little strange. I'm hoping the first few were straightforward, but this one is not. So sine of cosine inverse of 1/2 plus sine inverse of 2/5. So it looks super weird. So do you remember those questions we had? We had like sine of tangent inverse, and we built the triangle. It's going to be very similar. You can also use your formulas, but you just have to do it twice. So this is like my alpha and beta, this cosine and the sine. So what I want you to do is let alpha equal cosine inverse of 1/2 and beta equals sine inverse of 2/5. Apply your definition. That means there's a cosine alpha that equals 1/2, and there is a sine inverse. I'm sorry, a sine beta that equals 2/5, right? The range of cosine inverse is between 0 and pi. The range for sine inverse is going to be -pi/2 to pi/2, right? So using those ideas, I can kind of figure out where the alpha and beta are. Now, on the 0 to pi means the top half of the circle, correct? You agree that cosine is negative in quadrant 2, but not quadrant 1. But if cosine alpha is equal to 1/2, it must be quadrant 1. So using this and looking at that, this is quadrant 1. This is quadrants what? 1 and 4. Right, so the right half of the circle. If sine is positive, it has to be quadrant 1 as well. Does that make sense to you? Yeah. So these are given to you by the range of the inverse functions. So this is just a fact right here. Okay. So then we look at the circle. I don't think I have mine open. See if I can find it. Actually, it's in here. Somewhere. I have too much stuff. So hopefully nothing weird pops up, you know. All right. Let me zoom in here. Zero to pi is this top half of the circle. And then they told me that cosine was equal to 1/2. So that means it has to be over here because this is the only place where cosine is positive between 0 and pi. So it's basically hinting I'm over here. That's where alpha, the angle alpha is. Sine is defined from here to here, but they forgot to share the screen there. Sine is defined from -pi/2, which is down here, all the way to pi/2, which is up here. So the right half of the circle is going to be your range for the inverse sine. So beta is over there somewhere. Okay. But then they told us that sine beta is equal to 2/5. So that means the y value has to be positive, and it's negative down here. So I have to be over here. Does that logic make sense to you? So we're kind of figuring out with these clues where the angle is, because they didn't tell us straight up. They didn't say alpha's over here, beta's over there. And we need to know that to use the correct formulas. So let's switch back here.
Yeah, we just like. Do the quadrant.
we can assume it's one of the positive quadrants. But I don't know, because right now I'm gonna have to solve for sine alpha. So I need to figure out, okay, is sine gonna be positive or is sine gonna be negative? So I need to know exactly which location. So, because if I only have this piece of information, it's either gonna be 1 or 4 for cosine. For sine, it'll be either 1 or 2.
Isn't cosine?
Cosine is negative on quadrant 2 and 3. Cosine, but it's defined between 0 to pi. So this piece guarantees quadrant 1. These pieces together. Okay. So that's how I reason what quadrant we're in. Once we know, because none of this will be given to you. Right? On an exam, I'll probably tell you this piece. But on these homework questions didn't tell me any of this part. It was just like blank there. All they gave me was this top part. Okay, that's all you're given. So you got to reason your way through this. But once we have that, the next part's pretty straightforward. If you remember, either draw a triangle or remember that sine theta is equal to plus or minus the square root of 1 minus cosine squared theta. Right? If you look at your Pythagorean formulas, you solve for sine, the ones I gave you last time. Solve for sine yourself, and you're going to get this. Solve for cosine yourself, you'll get this guy. Right? I'm just square rooting both sides of the Pythagorean formula. So I'm skipping that step and I'm just giving you the formulas. Because I need to find sine alpha. Okay, so I need sine alpha. So first step here is solve sine alpha, alpha not theta. Okay. Sine alpha will equal plus or minus the square root of 1 minus cosine alpha squared. So this is where you need to decide. Is sine negative? Right. We're in quadrant 1. Since I know this now, I'm going to choose positive. And cosine was given, so that would be 1/2 squared. Did you see why we chose plus? Yeah, that's why this is important, this part here. So now just do your algebra, solve for sine. The 1 minus a fourth, which will be square root of 3/4, which is square root 3 over 2. Now I need cosine sine alpha, cosine. Oh, I'm sorry. I was solving for sine alpha. Yeah, I'm good. Sorry, I thought I mislabeled it. Now we're gonna do cosine beta. Because we have sine beta, we need the cosine beta. Do you see what we're solving for these? You see we're gonna use that same formula, right? The sum and difference of angles. So I need the other two parts. So cosine beta will equal plus or minus the square root of 1 minus sine squared beta. So we're going to choose plus because we are in quadrant 1. Okay. So this will be square root of 1 minus 2/5 which will be 1 minus 4/25, which will be hold on a second. This is supposed to be a 3. This is a 3. Minor change. Luckily, I caught it early. So it becomes a 9. 1 minus 9/25 will be 16/25, right? Will be 4/5. Okay. So now we can answer the question. Sine alpha plus beta is equal to sine alpha cosine beta plus cosine alpha cosine alpha sine beta. So remember that your alpha is cosine inverse of 1/2. Your beta is sine inverse of 3/5. This should be a 3 up here. So we have all the pieces now. We were given cosine alpha and sine beta. We're given these two pieces. We found these two just now. Now we can answer the question. Sine alpha is square root 3/2 times cosine beta, which is 4/5, plus cosine alpha 1/2 sine beta 3/5. So that'd be 4√3/10 plus 3/10, which is 4√3 plus 3/10. Anyway, this is just fractions, who cares? But does the concept make sense?
So we
No, it's not on the unit circle. 3/5. You could use triangles instead of these formulas, but you would have to choose plus or minus when you do the Pythagorean formula. So it'll end up being similar. The end will be the same. Choosing the sign will be similar. Any questions on this one?
Which is important.
Square root of 16, square root of 25, 4/5. You get a common denominator, you subtract them, you'll get 16/25. I didn't show that LCD part.
What does it say right after this? First equal. Is it like sine? Beta equals to the-
Sine squared beta.
No, down. The left.
Here, at the bottom or up here?
Hey, at the bottom.
Yeah.
After the first one.
Sine alpha cosine beta plus cosine alpha sine beta.
Oh.
Is it the B that's weird?
It's been the first part.
That better?
Yes.
Sorry about that. I know I don't have the best handwriting. So just let me know at any point. I'll write worse than my doctor.
That's not.
I think the hardest part is choosing the quadrant. And after that, you're just using a formula. Now, I'll wait a bit for before I change the page.
Like, because you're not gonna homework, we're not gonna give this information, right?
Right.
And so like, how would you like determine like, the quadrants?
So this is determined by where cosine inverse is. Like this is something that's defined 0 pi, and this is the for inverse sine. So these you should already know, or you should have written down somewhere for inverses. And then I use this fact and this fact to determine which quadrant. So these two ideas together. Okay, because you need that information to narrow it down. Otherwise, you can't choose the correct sign.
That's reasonable.
No, they're not the same. If it was root 3, then yeah. This is like 4x plus y or something. They're not the same.
If it was 3 plus root 3, what would that be?
That would be 5 root 3. So to add roots, they have to be exactly the same. We'll do one more and then give you your test back. You guys cool on this page? Okay. Example 4. So given sine alpha equal to 3/5, and alpha is between 0 and pi over 2, and cosine of beta is equal to negative 5/13, where beta is between pi and 3 pi over 2. So here I'm kind of giving you more information, but this is actually given to you. And it should be enough to determine the quadrant. What quadrant is alpha in? Can you tell? That sign is positive, and they're telling you 0 to pi over 2. So let's go to your circle. 0 to pi over 2 is the first. Yeah, has to be. Okay. What about beta? Yeah, that's going to be 3. So now we'll know when we start doing the sine stuff. Okay. They want us to solve sine alpha plus beta, cosine alpha plus beta, tangent alpha plus beta. But as you can see, we're going to need cosine alpha and sine beta. Those are missing. Okay. Use that same formula. All right, let's find do cosine alpha first. Cosine alpha is equal to plus or minus the square root 1 minus sine alpha squared. Do I choose plus or minus? Yeah, we're in quadrant, oh, alpha's in quadrant 1, so yeah, cosine is positive. Okay. So that'll be square root of 1 minus sine alpha squared. That'll be 1 minus 9/25. LCD, I'll go ahead and do it this time. That'll be what, 6? Yeah. Same as last time, 4/5. Now let's solve for sine alpha. I'm sorry.
So the positive and negative is based off whatever is inside the square root, like if it's either 5 or
Yeah, you choose the plus or minus to, so you look at the cosine and you decide, am I negative or positive? And that's determined by the quadrant. Cosine is positive here, so you choose plus. Sine is sine positive or negative in quadrant 3. So we choose the minus. Does that make sense? Okay. So now it's negative. 1 minus cosine squared. Cosine squared is right here. Negative 5/13. That's 13 squared. One minus 25 1/69 would be 144 1/69, which is 12/13. Okay. But negative, yes.
So after the first step, should the sign,
This becomes positive, but there's a minus weighting. So you square it to become positive. And then there's another minus,
um,
right? Because the exponent comes first.
so it's like,
From here to here? No, you subtract these two and you get 144.
uh,
Because if you get the common denominator, this would be 169 over 169.
uh,
169 minus 25 is 144. I just skipped that step. Yeah, you guys see that? Is that okay?
have you ever given tan alpha? Like
They could, yeah. Um, if they are, I think the easiest way would be to build a triangle, or yeah, I think a triangle would be best. You could try to use identities, but it would be more work. So those are two answers. So now we can solve A. Alpha plus beta that would be equal to sine alpha cosine beta plus cosine alpha sine beta. So just plug in what you know. That will be 3/5. Cosine beta is -5/13 plus cosine alpha is 4/5. Sine beta 12/13. So this will be -15/65 minus, what is it? 48, right? 4 times 12. So -15 minus 48. 63, right? Yeah. RB. Any questions on what we're doing here? Does it make sense? Is it okay? What's up? Yeah. Is that good?
Following cosine alpha isn't cosine alpha.
We were given sine alpha and cosine beta. Oh, okay. Yeah, no worries. So we just found the pairs that were missing. That's what we did here. We chose the signs according to the quadrant, and once we had everything, you just put them into the formula. That's it. All right. Part B. Now that you have everything, it's not a big deal. You're just plugging stuff in. This would be cosine alpha, cosine beta minus sine alpha, sine beta. So that will be cosine alpha 4/5, cosine beta -5/13 minus sine alpha 3/5, and then sine beta. So this will be -20/65 minus plus 36/65, which is 16/65. I'll leave tangent to you. Just makes sense to you.
sixth grade.
Yeah.